Hello, welcome back. Today we're going to be covering the depth first search graph traversal algorithm. So first of all, what's a graph? It's similar to a tree, but it's representative of a real-life problem or concept. So you could maybe imagine that these are all airports, and if you want to find if there's a way to get from one airport to another, you could use depth first search to find a path. Now, if you wanted to find the shortest path between two airports, that would be more suited towards breadth first search, but I think this is a good starting point. I think it's easier to comprehend than breadth first search, and it's a good way to get ready to learn that one. So really there's 4 steps in this algorithm. You want to add the node to the stack, mark it as visited. You want to go to its unvisited neighbors and add those to the stack, and once you've reached a node's, once all of the node's neighbors are visited, then you pop it off the stack. So I have my graph here of 8 elements. I've got where I'll put my output, and this will represent my stack. So we can start on any node we want. Just to be consistent, I'll start on A here. So step 1, add it to the stack. Step 2, mark it as visited. Okay, and now we have A in our output. Now we have all these neighbors. So we have F, H, C, and D. And for this, we're going to be going to the neighbor with the lowest key value. So that will be C. So we'll add it to the stack. Mark it as visited. Okay, and now we repeat the process looking for unvisited neighbors. So what's the neighbor with the lowest key value? In this case, it's B. So we go to B, add it to the stack, mark it as visited, and we'll put these in our output. Okay, same thing again. B has another unvisited neighbor. This time it's D, so we add that to the stack, mark it as visited, and put it down in our output. Okay, so now does D have any unvisited children? It absolutely does. D has E. Okay, so let's add that to the stack, mark it as visited, put that in our output, and once again it has an unvisited neighbor, which is G. So let's put that on the stack, put that on our output. Okay, and mark it as visited. Does G have any unvisited neighbors? No. So what are we going to do? Well, we're going to pop off G from the stack. Okay, so now we're back at E. Does E have any unvisited neighbors? No, it doesn't, so we pop it off the stack again. What about D? Does D have any unvisited neighbors? No, it doesn't. Okay, B, no, we pop it off the stack. C, no, we pop it off the stack, and now we're back at A. So does A have any unvisited neighbors? Yes, it does. It has F and H. F is the lower one, so we'll pop that, put that in the output. Okay, does F has any unvisited neighbors? Yes, it does. It has H, so we'll pop that, or put that on the stack, mark it as visited, print it in our output. Does H have any unvisited neighbors? No, pop it. F, no, pop it. A, and we've visited all the neighbors of A. So now our stack is empty, and our depth first search is done with the output A, C, B, D, E, G, F, H. And there you go.